In this module, you will learn about kinetic energy. We learnt about potential energy in objects with reference to a specific level. However, what happens when these objects are in motion? For example, when a coconut drops from a tree onto wet sand, we can see a depression where the coconut dropped on the sand. In motion, the coconut does some work because it now has energy due to its movement. The energy possessed in a moving object is called kinetic energy. Now, let's see what happens if we again drop the coconut from a lesser height, say 1 meter. It still makes a depression on the sand. However, this depression is not as deep as the one it made earlier. That's because the first time, the coconut was dropped from a greater height and hence had higher speed. This gave it more energy to do work. Thus, more work was done when the distance travelled by the coconut was more. Let's derive the formula to calculate the kinetic energy of a moving object. Consider an object of mass m initially at rest. Thus, its velocity initially u is 0. Let us assume that a constant net force F acts on the body for t seconds and brings it to motion in the direction of the force. At the end of t seconds, let v be its velocity, s be its displacement during the interval t, and a be the acceleration produced in the body. The amount of work done is the product of force applied and the displacement caused by the applied force in the direction of the force. According to Newton's second law of motion, force is mass times the acceleration in the body. This makes the work done equal to the product of mass, acceleration and displacement. Let this be equation 1. According to the equations of motion, for a body in linear motion, the relation between initial velocity u, final velocity v, acceleration a and the displacement of a body s is given as v square is equal to u square plus twice the product of a and s. Thus, acceleration a is equal to v square minus u square divided by twice s. Let this be equation 2. Substituting equation 2 in equation 1, we get the work done as half of mass m multiplied by the difference of v square and u square. As the final velocity v of the body is greater than its initial velocity u, the work done is equal to the change in its kinetic energy. However, the initial velocity of the body is 0. Therefore, we get kinetic energy as half the product of mass and velocity squared.